Okay, now what we're going to do on this next part is graph the equation. This is an equation. The variable y needs to be equal to -5 times x plus 3. Now, I have integers, and both integers means not a fraction, not a decimal. I have non-integers in every number I have in this equation. So what I'm going to do, whenever the y, I'm going to just simply make an xy table. And since I don't have any fractions, they're integers, okay? We're going to do input values of 0, 1, and 2 for x. So if y equals -5 times x plus 3, I'm going to replace x with 0, okay? So -5 times 0, that's not a -3, okay? It's just a speck mark from the graph. So I take -5 times 0. You should know that in your head. It's 0 plus 3 is 3. So if x is 0, y is 3. Y equals 3. Okay, if x is 1, well, -5 times 1 is -5. And then -5 plus 3 is -2. So if x is 1, if I replace x with 1, y output is -2. Now if I use 2 as an input, -5 times 2 would be -10. And then -10 plus 3 is -7. You kind of do it on your calculator. If you do, you got -5 times, but x is out, 2's in, and then plus 3 is -7. Okay, same with 1. -5 times 1 plus 3, -2. All right, now we need to graph these. So if x is 0, y is 3. So 0 on the x in the middle, and y is 3, 1, 2, 3. I'm done numbering the plane. You can do that if you want. I'm not. Okay. X is 1, y is -2. So I go to 1, down 2. And I could keep going on this table. I could go 3, 4, 5. I could go forever. Okay. I'm not going to, but 1, -2. Then 2, -7. So I go right 2 on the x, and -7 on the y. Okay, now this graph is continuous because I could keep going. I could also have gone this way and did -1, -2, -3. Okay, so since the graph's continuous, we take a ruler or straight edge, something to draw a straight line with, and just make a line through those points because they do line up. And I put arrows on each end to show that the graph continues. It's continuous. Okay. And on this graph, what I write is just the equation. Y equals -5x plus 3. Because that's the equation for it. Okay, now the next one, up here I just had integers, so I use 0, 1, 2, but here 1/5's not an integer. So what I'm going to do to make it easier on myself, if I'm doing input, output, this is what this is called. It's called input, output. You're putting in a number for x, you get an output for y. However, if x has a multiplier that is not an integer, you're going to start with 0, but then what you're going to do is multiples of the denominator. So instead of 0, 1, 2, I'm going to go 0, 5, and 10, because watch what's going to happen. Now, we should know this in our head. 1/5 times 0 would be 0, but if I subtract 4, I get -4. Now, with the 5, 1/5, ABC, times 5, minus 4 is -3. Because 1/5 times 5, it's like when you multiply two reciprocals, the product's 1. 1 minus 4 is -3. Okay, then I take 1/5 times 10, a fifth of 10, and minus 4, -2. That makes sense because that 1/5 times 10 is like 10 divided by 5, which is 2. Minus 4 is -2. All right, so that's good enough. I just need 3 kind of points. So this is the x, this is the y. So if x is 0, so in the middle, y is -4, so I go down 1, 2, 3, 4. And that's 0, -4. Okay, x is 5, y is -3, so I go to +5 on the x, and I go to -3 on the y, 1, 2, 3. Okay, 10, negative 2. So I go to 10 on the x. So, whoa. Kind of ran out of space there, didn't I? Because I can't really, because I go 1, 2, 3, 4, 5, 6, 7, 8. Now I'll go 10 here. And then I go down 2. Okay, so that's 10, negative 2. Okay, so the points do line up. You just take a ruler or straight edge and connect them. And you kind of write the equation on the line. So y equals anywhere on this line, any coordinate on this line makes the equation true. Okay, any coordinate on this. You can take 1/5 times the x coordinate, subtract 4, and it equals where the y is at. I'm not a big fan of graphing, but I mean, I have to teach it. Okay, y equals negative x plus 3. Now, negative x means it has a multiplier of negative 1, so it's negative 1 times x plus 3. Again, the x is being multiplied by an integer, so I can just do 0, 1, 2. So negative 1 times 0 would be 0, and 0 plus 3 is 3. So if I input x, 0 for x, I get an output of 3 for y. It's called input-output. If I put a 1 in for x, negative 1 times 1 is negative 1, plus 3 is 2. And then put a 2 in, negative 1 times 2 is negative 2, plus 3 would be 1. Okay, so easy graph, 0, 3. So this is the x, this is the y. So I stay in the middle and I go up, 1, 2, 3. That's 0, 3. Okay, x is 1, y is 2. So I go to 1 on the x, 2 on the y. And that is 1, 2. And then I go to 2 on the x and up 1 on the y. And that is 2, 1. Okay, now take your ruler and connect the points. Make arrows because the graph's continuous. Okay, so you connect it. And on this line, somewhere where you have room, just write the equation. Y equals negative 1x plus 3. So any x. So let's take this, you know what I'm saying? So this point right here, x would be negative 1, you know? Well, negative 1 times negative 1 is 1 plus 3 is 4, and that's exactly where we're at on the y, okay? If we have x at negative 2, negative 1 times negative 2 is 2, plus 3 is 5, exactly where I'm at on the line for the y. Y is up at 5 then, okay? That's what a graph does. Okay, and then the last one, y equals negative 1/2 x plus 4. Now again, if x is being multiplied by a non-integer, a fraction, I'm going to go 0, but then I'm going to go by 2's this time, 2 and 4. So the 0 is easy. 1/2 times 0 is 0, plus 4 is 4. So the input 0, output 4. Negative 1/2 times 2. That's negative 1, and then plus 4 gives you 3. Now, we should be noticing that these go in patterns. So if I go 4, 3, what would be the next integer? Would be 2. Okay, so if x is 0, y is 4. So this is x, this is y. So 0, 4. Stay in the middle, then go up 1, 2, 3, 4. Okay, so 0 and 4. X is 2, y is 3, so I go to 2 on x, I go to 3 on y, so that's 2, 3, 4, 2. I go to 4 on x, I go to 2 on y, so that's 4 and 2. Now, take your ruler, and it's continuous, so I need arrows. And somewhere on this line, you just write y equals negative 1/2 x plus 4. Okay, so let's look at that equation. I'll just prove it works. So let's say x is negative 2 right here. Okay, so I'm going to take negative 1/2 times negative 2 and plus 4. So it's 5, which makes sense because I see -2, 1, 2, 3, 4, 5. Exactly, okay? Any point on that line satisfies the equation. Okay, can you do the 3 and then before you move on to the next assignment?